morning, students. Chapter 4, motion in a plane, continue. Yes, last theory of this chapter, but again important theory, uniform circular motion. What is uniform circular motion? What is its definition? If you understand this each and every term, uniform, so what is the meaning of uniform? Which term remains uniform? Circular motion. So yes, from this you can easily say object moves on circular path. Yes, it is right. Okay. When object moves on circular path, when object moves on circular path, when object moves on circular path with uniform speed, see, most important point, when object moves on circular path with uniform speed means constant speed, it is called uniform circular motion. Clear? When object moves on circular path with uniform speed, that is constant speed, it is called uniform circular motion. For example, it is a circle, its center. Okay, let object is moving in anti-clockwise direction. Okay, yes, here in uniform motion, speed remains constant, not velocity, because we know that velocity at a point is in direction of tangent. Okay, here velocity is in direction of tangent at that point on its path. So if at this point, if I want to say what is direction of velocity, it is in this direction. Okay, if at this point, if I want to say what is direction of velocity, it is in direction of tangent. If at this point I want to say what is direction of velocity, it is in this direction. At this point, velocity, it is in this direction. See, each and every direction is different. So yes, here velocity means vector quantity, magnitude and direction both. Here, direction of velocity continuously changes. Okay, here direction of velocity continuously changes. Uniform speed means what? But its magnitude, that is speed, remains constant. Clear about this? So yes, velocity is vector quantity. Direction of velocity continuously changes, but its magnitude, which is called speed, it remains constant. Now as velocity changes, yes, here velocity changes, yes, direction changes, magnitude, it remains same. But direction changes, means velocity changes, so it is called accelerated motion. Clear about this? So yes, this uniform circular motion is accelerated motion. Clear about this? Again, when object moves on circular path with uniform speed, not velocity, okay, it is called uniform circular motion. We have a circular path, center, velocity, vector quantity. At each and every point, direction of velocity is in direction of tangent. Direction of velocity, direction of velocity, direction of velocity. Okay, so yes, here direction of velocity continuously changes, but its magnitude, that is speed, it remains constant. Okay, if here speed is 10 meter per second, here your speed is 10 meter per second, here also speed is 10 meter per second, 10 meter per second, but direction at each and every point different. So yes, if direction changes, velocity changes, and it is called accelerated motion. Now accelerated motion means, yes, you have to find what is direction of acceleration and what is magnitude of acceleration. So see how to find direction and magnitude of acceleration. Okay, we will draw one figure. See, here it is a circular path. It is a circular path. Center, okay, O. Its radius is capital R. Radius of circular path. Radius of circular path is R. Okay, let at some time, at time t is equal to t, at time t is equal to t, particle means object in motion is here at point P, at point P. So from center, it is its position vector R. We know that velocity at any point is in direction of tangent. Let it is moving in anti-clockwise direction. Okay, so at this point, its velocity is in this direction. It is v. Clear about this? Okay, let at some time t is equal to t, object is at point P, R is its position vector, velocity is, yes, velocity is in direction of tangent. Now students, you know that R, it is radial direction, it is tangential direction. So yes, this R and P, they are perpendicular to each other. Okay, here let at time t is equal to t, object is at point P, having position vector, R, and velocity v, and yes, from figure it is clear, it is radial direction, it is tangential direction, so I can say R is perpendicular to v. Yes or no? Yes, we can say. Okay, now object is moving in anti-clockwise direction, moving. Let at some time, after some time, object is here at this point. At time t is equal to t dash, it comes to point P dash. Okay, its position vector is R dash. Okay, and its velocity, yes, it is in direction of tangent. It is in direction of tangent, so it is v dash. Clear about this? Okay, so yes, at time t is equal to t dash, object is at point P dash, having position vector R dash, and velocity v dash. Clear about this? Velocity v dash. At time t is equal to t, at point P, R is perpendicular to v. At point P dash, R dash is also perpendicular to v dash. R dash is perpendicular to v dash. Clear about this? Okay, so yes, initially at point P, moving, then at point P dash. Okay, now see, if I draw displacement vector, initially it is at point P, then at time t is equal to t dash, it is at point P dash. So what is displacement vector? Delta r dash, it is in which direction? See. Yes, my hand is moving in this direction. So in which direction? That is displacement vector. Displacement vector is in this direction. It is called delta r. It is called delta r. And let object is moving angle theta. Object is moving angle theta when it moves from point P to P dash. Okay. So yes, how to write? Okay, let displacement vector is as shown in figure. Let displacement vector is delta r is as shown in figure. Here it is displacement vector. Now see students, now what you have to understand. See, initial position, final position, displacement, change in position. It is initial velocity, it is final velocity. So yes, what is change in velocity? What is direction of change in velocity? Delta v. See, as r is perpendicular to v, r dash is perpendicular to v dash. If I find delta r dash, that is change in position, and delta v, that is change in velocity, they are also perpendicular to each other. Remember, because as r changes, r and v, they are always perpendicular for circular motion. R and v, they are always perpendicular for circular motion. So yes, as r is changing its position, v also changes its position. Clear about this? Okay, such that they are perpendicular to each other. Okay, so if I am taking here one point, okay, from this point, if I draw this initial velocity in this direction, that is v, clear about this? Okay, from the same point, if I draw final velocity, that is v dash, it is in this direction, v dash. Yes or no? Then yes, it is initial velocity, it is final velocity. Yes or no? Then yes, delta v is in this direction. And see, this delta v is perpendicular to delta r. Yes, you have to take this condition, as r is perpendicular to v, r dash is perpendicular to v dash. Delta v is also perpendicular to delta r. Change in velocity is also perpendicular to delta r. Clear about this? Okay, so yes, let displacement vector is as shown in figure. Now change in velocity, delta v is also perpendicular to delta r. Simple. R perpendicular to v, r is perpendicular to v dash, then delta r is also perpendicular to delta v. And now see, acceleration, vector quantity. What is direction of acceleration? In direction of changing velocity. So yes, we know that average acceleration is in direction of change in velocity, delta v. So therefore here direction of average acceleration is perpendicular to delta r, because see, average acceleration is in direction of change in velocity, in this direction, and it is perpendicular to delta r. And see this arrow, it is towards the center, and it is towards the center of circle. Clear about this? So yes, here average acceleration during its journey is towards the center. So yes, it is first point that you have to remember. Okay, again, initially at this point, finally at this point. Initial position, final position, displacement, change in position. Initial velocity, final velocity, change in velocity. R perpendicular to V, R dash perpendicular to V, so obviously delta R perpendicular to delta V. Delta V, acceleration is in direction of change in velocity. Change in velocity is perpendicular to delta R and it is towards the center. So yes, acceleration is towards the center of circle, average acceleration. Okay, now we will take time interval very small. Okay, now we will take time interval very small, and yes, you know, if we take time interval small, average acceleration will become instantaneous acceleration. Then what is direction of instantaneous acceleration? See, we will see. Okay, now again we will draw one circle. See, yes, circular path, its center O. Okay, initially it is at point P, its position vector, yes, here it is R, its initial velocity, yes, it is V. Okay, now let we are taking time interval small. So let object is here at this point, at point P double dash. Okay, so its position vector is here, it is R double dash. Clear? Its velocity here it is in direction of tangent V double dash. Clear about this? Clear about this? Yes or no? Yes. Okay. Yes. Angle between them is, yes, here it is theta. This angle is, it is theta. Okay. What is displacement? Yes. It is displacement vector. It is displacement vector delta R. We know that V is perpendicular to R. Yes. V double dash is perpendicular to R double dash. Then if I say change in velocity, then that change in velocity is also perpendicular to delta R. Also perpendicular to delta R. If I draw a bisector from this, okay, then yes, delta V must be in this direction. Delta V must be in this direction. Clear? And yes, it will be. See how, if I am taking here one point, initial velocity is in this direction. See, it is direction of V. Okay, final velocity is in this direction. Final velocity is in this direction. And if I draw change in velocity, then obviously that change in velocity is in this direction. Delta V. It is delta R. Clear about this? Clear about this? So yes, if I am taking time interval small, yes, R is perpendicular to V, R double dash is perpendicular to V, delta R is perpendicular to delta V, and yes, it is direction of average acceleration. Average acceleration. Clear about this? Clear about this? Okay, so if I am taking time interval very small, what happens? If it is circle, particle is here at this point, in direction, it is direction of velocity, then direction of acceleration will be in this direction. Yes, see, here delta V is towards center, here delta V is towards center, means acceleration is towards center. So yes, first conclusion of this theory, here acceleration of object is towards center, in radial direction. Therefore acceleration is called radial acceleration. radial acceleration or centripetal acceleration or centripetal acceleration. See, from this three figure, what is conclusion? Only direction. The direction of acceleration is towards center. Direction of acceleration is towards center in radial direction. And that's why it is called radial acceleration or centripetal acceleration. Now we will obtain its equation. We will obtain its equation. See how? Initial position R, final position R double dash, angle between them is theta. R is perpendicular to V, R double dash is perpendicular to V double dash. As particle has moved angle theta R to R double dash, V is also changing and always R is perpendicular to V. So if angle between R and R double dash is theta, angle between V and V double dash is also theta. It is also theta. Clear about this? Okay. So this point you have to remember. How? R and R dash. Angle between them is theta. R and V, R and V, R and V, R and V, they are always perpendicular. So yes, if this R sweeps angle theta, V also sweeps angle theta. Clear about this? Okay. See, it is radius. Yes or no? Yes, it is. R double dash, if I find its magnitude, it is also radius. R double dash. Radius. Yes or no? Means two equal sides, angle between them is theta. Two equal sides, angle between them is theta. Here, in this triangle, V double dash. V and V double dash is velocity, but its magnitude means speed. It is constant. It is constant. Yes or no? Yes, it is. So this V double dash. If I find their magnitude, see how to write their magnitude. R, its magnitude is equal to R double dash, its magnitude. It is nothing but radius, students. Yes, magnitude, see, it is magnitude is same. Here, V is equal to mode of V double dash is equal to nothing but speed. Speed is constant. Remember its definition. Okay, so yes, these two sides are equal, angle between them is theta. These two sides are equal, angle between them is also theta. So yes, from this we can say these two triangles are equal triangles. Yes or no? These two triangles are equal triangles. And now, if in this equal triangle, if I am taking ratio of these two sides, means if I am taking ratio delta V upon V is equal to, here what is base? It is delta R, is equal to, it is delta R upon R. Clear about this? Okay, so yes, you have to take ratio in these two similar triangle. Clear about this? Okay, now make delta V as subject. So delta V is equal to, it is delta R upon R. Here it is V. Here it is V. If I find its magnitude, then how to find its magnitude? It is mode of delta V is equal to mode of delta R. Only V, that is velocity. Its magnitude. Yes, here it is V. Okay, R is magnitude, here it is R. Clear about this? Now average acceleration. You know average acceleration. Average acceleration delta A is equal to, it is delta V upon delta T. Yes, here it is. Okay, so is equal to mode of delta R upon delta T, V upon R. If I am taking limit delta T tends to 0, limit delta T tends to 0, then instantaneous acceleration, How to write instantaneous acceleration? Yes, A is equal to limit delta T tends to 0, delta V upon delta T. What is delta V upon delta T? Is equal to, it is limit delta T tends to 0, delta R upon delta T, V upon R. And we know that limit delta T tends to 0, delta R upon delta T is nothing but V. So A is equal to, here it is V upon R. So A is equal to, here it is V square upon R. A is equal to, here it is V square upon R. Clear about this? If, yes, V is speed, here it is magnitude, okay? So yes, V is speed, then we can say it is only its magnitude, okay? Okay, A is equal to V into V upon R, A is equal to, it is V square upon R. And yes, you have to remember this equation. Okay, if object is moving on circular path, of radius R with constant speed, V, its radial acceleration or centripetal acceleration, AR is equal to V square upon R. You have to remember this equation. Okay, equation is simple, V square upon R. Direction is important. Now see, in this figure, one last point. In uniform circular motion, acceleration is always towards the center. And yes, we know that velocity at any point is in direction of tangent. If I am taking this point here, velocity is in direction of tangent. And what about acceleration? Towards the center. Yes or no? Yes. At this point, velocity is in direction of tangent. Acceleration is towards the center. To see, yes, magnitude of acceleration remains the same, but velocity vector is towards the center but changes continuously. So velocity vector is not constant. Sorry, acceleration vector is not constant. This point you have to remember. Magnitude of acceleration is constant, V square upon R. But if I say acceleration vector, it is not constant. Okay, so yes, it is all about uniform circular motion. Again, what remains constant in uniform circular motion? Speed remains constant. Velocity is not constant. Velocity means magnitude and direction both, and from figures it is clear the direction of velocity continuously changes. So remember, uniform circular motion, speed remains constant, not velocity. Okay.